slide?
Not yet.
Right. Okay, here we are now. Let me see. I have to do it again. Oh dear. Right, okay. End show. Do it again. Can you see any slide?
Just a second. I'm not able to, Franco.
Okay. Share contents now. Presentation.
Yes, it's come through.
Done now.
Yes, I can see it. Yes,
so you got the full
perfect.
slide, isn't it?
Yes, I can see the full slide now, Franco.
Fantastic. And if I move forward, you see the next one.
Yes, it's working.
Done.
All right. I'll introduce you, Franco, and then I'll leave the floor to you. So, welcome everyone to the Health Sciences seminars today. Few housekeepings. Can I request everyone turn off their webcams so that we have sufficient bandwidth and everyone can hear clearly, as well as see the slides clearly? Can I also request that if you've got any questions, make a note of it, and then towards the end, which would be about 35 to 40 minutes, you raise your hand and ask the question, or if you would prefer to ask the questions in the chat box, that's welcome too. I take great pleasure in introducing Franco. A brief bio of Franco. Franco moved to Warwick in July 2005. He's a cardiovascular physician, a clinical epidemiologist, and a public health expert. After his medical degree in Naples, he moved to Britain, where he trained at Charing Cross Hospital, St George's Hospital Medical School, and the London School of Hygiene and Tropical Medicine in London. In 2000, he became Professor of Clinical Epidemiology and Primary Care at St George's University of London. Franco is going to talk to us today about the search for causality, the case of sleep deprivation and chronic disease. He says that this is designed as a case study for the application of the Bradford Hill criteria for causality in observational epidemiology. So Franco, thank you so much. Over to you.
Well, thank you very much, Vivek, and then welcome everyone who's joined. I think the presentation will become very clear. It's been created with a teaching objective in mind, hoping that many PhD students and early career researchers would join us. So apologies for some of my more senior colleagues who might find this a bit basic, but it is I use a real case study in my research experience in the last 15 years at Warwick to describe the main challenges we find when we use observation epidemiology in determining or implying a causality between an exposure and an outcome. Let me see if I can just move. Okay. This case study illustrates the course we followed with our team and joined with Michelle Miller, who was with me leading on this, over the past 15 years in trying to establish a causal link between short duration of sleep and risk factors of cardiometabolic disease and hard vital outcomes. And as in most cases, the quest starts from a chance observation. As cardiovascular epidemiologists, we were all aware of the emerging epidemic of obesity in the Western world at the time, as indicated, as you see in the top panel, by the steady increase in the average body mass index of the American population, for instance, over time, and the associated rise in the prevalence of obesity. When we moved to Warwick, we were quite novices in the field of sleep medicine, but we were tasked to develop a new research program on sleep. So clinical epidemiology was our field. So we first went to look at time trends in the average duration duration of sleep, starting from the US, where data was available at the time. And on the bottom side, we found that Americans have steadily reduced their average daily sleeping time almost in parallel with their average weight gain. Could anyone reasonably conclude then from this observation that there was a causal connection between sleep reduction and weight gain? So the answer is definitely no. This is due to the flaw inherent in the correlation between an average exposure with an average outcome, which introduces to us the concept of ecological fallacy. And let's define ecological fallacy. Ecological fallacy is an error in the interpretation of data that occurs when inferences about the nature of individuals are derived from inferences about the group to which those individuals belong. In other words, comparing group averages. This slide presents an ecological data association relating average self-reported duration of sleep obtained by questionnaire on the x-axis and self-reported poor health, also assessed by questionnaire on the y-axis, in samples of college students taken from different countries using the same methodology of collecting data. And although the results do not prove cause effect, as we've seen, the data tend to suggest that there is a lower threshold for average duration of sleep, below which there is an increase in self-reported ill health. And whilst the temptation to infer some sort of causality between these two measures is quite tempting, so when you sleep too little, then you experience more ill health. This set of data is not only open to the ecological fallacy, but is also cross-section. And what it means that the amount of exposure and the amount of outcome are collected at the same time point. We therefore decided, first of all, to move away from ecological evidence and to examine data taken in individuals. And the question we wanted to answer was, how much sleep do we need? Over the history of sleep, humans have adopted different patterns of sleep. We know that if you don't sleep, we eventually die. So this is an essential requirement for life. However, how much is the optimal requirement? We do not really know. And even as of today, we don't know. If we study current westernized population and we measure sleep duration, we detect a bell-shaped curve with the distribution of hours of sleep, as you can see on the left-hand side here. And in Britain, on the left-hand side, this is a representative population sample of men and women. And the majority of sleeping time clusters between 6 and 8 hours per night, with an average of about 7. If you look at the US population, the average is about 8 hours per night. But this is considering sleeping time only at weekends, which also makes the point that we use weekends to catch up. But whilst the majority of people do sleep around that average, and 1 in 4 people, the two tails represent about 25% of the population, either we can call it short sleepers by a free definition, or long sleepers. And this will help us then identify in the future the terminology. Having established that sleeping time can be measured in individuals, and many studies have somehow collected such data, we developed an a priori hypothesis, which I think is very important when you don't want to fall into the fishing expedition process. And so we set the hypothesis saying, does short sleep duration contribute to the development of chronic disease? And given our particular interests, we focus specifically on cardiometabolic disease. So we developed our model of hypothesis where the exposure to short sleep through a variety of pathophysiological mechanisms might lead to an increase in risk factors or a decrease in protective factors, leading to an increase in morbidity and mortality from a number of chronic diseases. Now, I need to take a bit of time on this slide. This slide reports the results of a systematic review and a meta-analysis of cross-sectional population studies. in which both sleep duration, in those days mostly was self-reported, and prevalence of obesity had been measured in large studies of children and adolescents, as shown on the left, and adults, as shown on the right. The graphs used are known as forest plots. Now, apologies for some, are very expert in that. I shall use a few minutes just to get through the concept and how we interpret these, because I will use quite a few in my talk. They report for each study the average outcome measure, which in this case is expressed as an odds ratio, and the corresponding 95% confidence intervals, the two bars either side, of the association between the exposure, that in our example is sleep duration, and the outcome, which is obesity. The likelihood of being a short sleeper if you're obese is measured by the odds ratio. And if it's greater than 1, indicates a higher risk. If it's lower than 1, indicates a lower risk. Now, if the 95% confidence intervals around the mean do not include 1, then the association is considered to be statistically significant according to standard criteria of chance, and it would tell us that these within a degree of confidence is unlikely to be due to chance. The pooled effect at the bottom is the result of a meta-analysis, which means put together all the different effects of different studies, allowing for their different size. So in both children and adolescents and in adults, those with obesity were more likely to be short sleepers, if you see the bottom of the pooled effect. The association was strong, and the strength is measured by the odds ratio. We have an odds ratio 1.55 for adults, 1.89 for children. And it was definitely unlikely to be due to chance, as the pooled 95% confidence intervals were not including 1. The meta-analysis also showed that although there was some heterogeneity between studies, there was no publication bias. Now, what can we say from these studies with confidence that short sleep is causally associated with the development of obesity? Having spent so much on time, the answer is still no, because these are all cross-sectional studies in which the exposure and the outcome are measured at the same time point. And I'll tell you why that is important in studies of sleep and disease. In general, observational studies are unable to answer one fundamental question, and in this case it's for sleep. Is the sleep deprivation a cause? Is that a consequence? Or is that a symptom? In the study of sleep deprivation and obesity in children and adults, the real possibility of a bidirectional model of plausibility, of biological plausibility, requires researchers to dissect out the direction. From one side, and this slide shows it, it is possible that sustained sleep deprivation through a chain of events, which I'll take you through a bit later, which might lead to an increase in energy intake and a reduction in energy expenditure, which in turn would be compatible with weight gain, would support this one-way direction. But on the other hand, we have some evidence that overweight and obesity are conditions often causing sleep disorder breathing, ensuing sleep fragmentation, and reduced sleeping time. And this is a process often referred as to reverse causality. So could either sleep be the cause of obesity or be the effect of obesity? Therefore, it is important that the observational epidemiology of these effects of sleep duration only takes into account prospective studies, in which the exposure of sleep deprivation precedes the development of weight gain or obesity, as well as other outcomes of interest. And this very large forest plot, I'm not expecting you to identify all the numbers there. This is a large forest plot that summarizes all the evidence now of prospective longitudinal cohort studies of the association between sleep duration and the incidence of obesity, of new cases of obesity in population studies in children and adolescents up to the age of 18. And these are published up to mid-2018. in which sleep duration was measured at baseline in the non-obese children, and the risk of developing obesity was recorded prospectively in the follow-up years. These studies unequivocally show the temporal sequence whereby short sleep duration precedes the development of obesity. In this case, the exposure is still short sleep and is strongly associated, the relative risk 1.57, with the outcome, which is incident cases of obesity. And the association is unlikely to be due to chance, as we see from the pooled all the different effects, that they don't include one. We can then say that these results are unlikely to be due to reverse causality and are compatible with the cause-effect relationship. I wanted to use another concept that this recent meta-analysis adds a bit of extra information to the previous one, where adds a further criterion in favor of causality, which is the consistency of findings, since short sleep is a prospective predictor of obesity even in cohorts of Chinese children and adolescents, saying that is across different continents and ethnic groups, you find the same effect, which tends to strengthen the concept that it might be causally related. Now, the next three slides very rapidly report some studies demonstrating the direct effect of sleep deprivation and also poor quality of sleep on glucometabolic mechanisms. All these experiments use a randomized crossover trial designs, but this time in normal volunteers in a strictly controlled laboratory conditions and subjected to short-term sleep deprivation. So bear in mind, although we can extrapolate some of these effects to what we've seen in epidemiology, the timeline is much shorter, and the sleep deprivation, although well controlled in the lab, is not sustained for longer. However, in this study that I show you here, 2 days of 4 hours per night sleep caused a reduction in leptin and an increase in ghrelin. These are two hormones regulating hunger and satiety, with a net result of an increase in hunger and appetite. So short sleep will stimulate appetite. Furthermore, the effect was dose dependent, as you see in the three bottom graphs going from right to left. You see that the leptin is reduced as the amount of sleep deprivation is increased. So the shorter sleep, the greater the reduction in leptin secretion. So we see a plausible physiological mechanism which might tie up with the risk of obesity with a dose response effect, which is reversible once you reverse the sleep deprivation. This is a similar study, shows the effect of short-term sleep deprivation on measures of glucose tolerance and insulin sensitivity in all the parameters that were used here, from glucose tolerance, glucose effectiveness, acute insulin response, insulin sensitivity, and disposition index. So short-term sleep deprivation causes a reversible glucose intolerance and insulin resistance. So these are still plausible mechanisms. And finally, I've selected this because this study is the only evidence, and very powerful, of a plausible molecular mechanism. This demonstrated in vivo in a randomized trial of normal volunteers, where the reduced insulin sensitivity seen during the short-term sleep deprivation, which I showed you early, is due specifically to an impairment in the phosphorylation of an enzyme called PAKT, which is the enzyme that helps transducing the message of insulin receptor binding to the membrane to the inner part of the cell to incorporate glucose. And of course, this effect is reversible once you extend sleep again. So plausible molecular mechanisms as well. So just to summarize this little bit, the progress through the step is to recap the evidence for causality from sleep deprivation that causes metabolic consequences. The first thing we have seen through the different studies, we've seen that if you reduce sleep, you increase appetite and you reduce energy expenditure. And this is mainly through short-term studies of sleep deprivation in normal volunteers. But that will provide, if time, a plausible mechanism to back up the evidence we find in the long term in prospective studies that short sleep relates to obesity. Now, that is consistent with the hallmark of obesity, which is a condition of insulin resistance and glucose intolerance. And that is shown also in intervention trials and is detected also in observational studies. But if that is the case, we would then predict that a condition of chronic insulin resistance and glucose tolerance may lead to the development of type 2 diabetes. Again, this is an a priori hypothesis which followed up by just looking at the observational epidemiology. This slide again there are three forest plots. This time, these show you the prospective associations between short duration of sleep and an increased risk of developing incident type 2 diabetes, not only in relation to sleep duration, which is the top, but also looking at quality of sleep, like difficulty in initiating sleep or difficulty maintaining sleep. So all these sleep disturbances do lead prospectively to an increased incidence of type 2 diabetes. The evidence is strong and is unlikely to be due to chance. Short duration of sleep, for the same token, also predicts the development of high blood pressure, as shown in this meta-analysis of prospective studies, and the risk is about 20% higher for those who regularly sleep less than the norm, which is less than 5 hours per night in adults in this particular analysis. So again, time sequence, strength, and consistency. For blood pressure, we have additional evidence to lead us to believe that there is a causal relationship. This is one of the early and few intervention-controlled trials of sleep extension in healthy volunteers. And then we go into now the intervention tool. These are two groups that were randomized to either maintain their sleep duration, approximately 6.6 hours per night, or to extend it by 1 hour per night. And these graphs indicate 24-hour blood pressure measured at baseline and after 6 weeks. The slide shows systolic and diastolic blood pressure at baseline, which are the blue lines, and at the follow-up, which are the red lines. In the sleep maintenance group on the left, sleeping approximately about 6.5 hours per night, and the sleep extension group, the intervention group on the right-hand side, where they were aimed at sleeping 1 hour longer. A period of sleep extension caused significant fall in blood pressure across day as well as night, as you can see on the right-hand side, with the two red lines being lower than the blue lines. The intervention extended total sleeping time by an average of 30 minutes when measured directly. So a randomized clinical trial is the ultimate proof of causality, that at least in the short term, if we were able to restore short sleep a bit longer, you would have a beneficial effect on blood pressure, even in normal volunteers. Now, we have so far seen a quick summary of evidence to support the view that short duration of sleep causes a variety of effects. We have looked at metabolic, vascular, hormonal, some molecular, and there's also some effect on gene expression, leading to the development of numerous risk factors: obesity, hypertension, and diabetes. Now, it is therefore reasonable to postulate, and we go to our hypothesis-led program, that long-term sleep deprivation might be found to be associated with a higher risk of cardiovascular outcomes. So, follow the a priori hypothesis. Let's see what happens. This is just a very brief summary slides would be. And the first three obviously are summary effects of meta-analysis for obesity, hypertension, diabetes, which I showed you. We have seen already that sleep deprivation predicts the incidence of obesity, hypertension, diabetes. In additional meta-analyses, we also reported an increased risk of developing fatal and non-fatal coronary heart disease, stroke, and surprisingly to us, premature death within 2 years of observation. Now, for the latter concept of premature death, there was a debate when we published the study on whether a single assessment of sleep duration by self-reporting would be a tool reliable enough to imply that the sleep deprivation was sustained during the follow-up period to be a sustained risk factor. In fact, sleep duration is one of these behavioral characteristics that can change substantially throughout our life course. So we therefore decided to look at the data in a different way. And we picked up the Whitehall 2 study, a cohort of British civil servants who are representative of the British population. So the study repeated observations every 5 years in their protocol, so that we were able to measure the exposure sleep duration at 2 time points 5 years apart, and to classify individuals in groups according to their sleep duration over a 5 years period. We took the reference group made of individuals who reported the same habitual duration of sleep on 2 separate occasions, so they didn't change. Those who reduced their sleep, where the duration went from 6, 7, or 8 to less, we considered to be sleep deprived. And those who increased from 5 or 6 to more as improvers, and those who had increased from 7 to 8 to more as long sleepers. And all were then followed up for 8 further years for vital outcomes. And irrespective of the model used to adjust for confounders, both those who reduced their sleep over time and those who increased it experienced an increased risk of death from all causes. However, those who reduced their sleep over time died mainly of cardiovascular causes, whereas the excess mortality in long sleepers was attributable to non-cardiovascular causes, suggesting some specificity of the effect of sleep on mortality type. So eventually we develop a model, and this scheme is complex, but really gives a summary of the wealth of evidence accumulated in the last 20 years, not only by us, but all other groups that worked on this area, to strengthen the concept that sleep disturbances are not only a problem for the brain and confined to the nervous system. Sleep disturbances involve almost every system and organ of the body, with far-reaching consequences in the short and the long term. Now, before I conclude, I'll take another few minutes just to go to the concept of causality. Now we establish causality. We do recognize in epidemiology that the association...
Students go to sixth form college where students go to university.
Sorry, can you mute it, please? We recognize that the associations may be present in the absence of a true cause-effect relationship. We can bump into associations, but they do not reflect cause-effect relationship. Epidemiological study design may be the reason, systematic and random variation, but also alternative explanations. And many of you may be familiar with this graph here, or the concept of causality, different models. You can have a model which is confounds the relation between exposure and outcome. There could be the intermediate mediator, or it could be just an alternative explanation. And if I give some example of these models, we can find, for instance, that manual workers are more likely to develop lung cancer. And obviously, we know that manual working is not the direct cause of lung cancer, but may be confounded by behavioral factors like smoking, for instance, which is associated with lung cancer, and independently of that association, it's also associated with manual occupation. Or we can have the model where there is an intermediate explanatory factors between low-fat diet and coronary heart disease, which is mediated through the rise in serum cholesterol. Or we can have a third type of model where you got smoking related to lung cancer, alcohol will relate to lung cancer, but people who smoke also drink more. So there is a mediation there. How do we deal with that? So how we interpret epidemiological association towards causality. First of all, we need to rule out the 3 key aspects. We need to rule out the role of chance, is the luck finding, and we do usually that with statistical inference. We have to rule out the role of bias. that we are fooled into an incorrect interpretation of our association, and there are several types of biases we need to avoid throughout the design and analysis of the study. And we need to rule out the role of confounding, that we make a mistake where we attribute to one factor rather than another, that either we haven't measured or we haven't taken into account. Now, the complexity of the interpretation of epidemiology was originally identified by this gentleman here, Sir Bradford Hill, who was an epidemiologist to put back in perspective, in those days, epidemiology was mainly observational epidemiology. And he developed some criteria to evaluate the strength of the evidence in favor of a cause-effect relationship. And that was being used and still being used today in the absence of an intervention clinical trial, randomized clinical trial. And in many aspects of behavioral epidemiology, when you have behavioral risk factors and long-term effects like diet, like behavioral changes, very often it is difficult or impossible or impractical to obtain a clinical trial. And nevertheless, you may set up policy, take policy decisions on observational evidence. Now, the next slide tells you, just for you to take home, all the Bradford Hill criteria to infer causation. And in fact, these are all the ones that I've showed you in the red boxes as we went through the talk. So I want to finish summarizing this case study, which I find it quite a very nice teaching tool now that we spent 15 years on that, to put in the context the use of Bradford Hill criteria. So far, we can conclude that the association between sleep deprivation and cardiometabolic disease may reflect causality strongly, has a strong hint from causality, because the effect measured is strong, is consistent, the exposure precedes the outcome, there is a dose-response effect, although in some is a threshold dose-effect response at either side of the curve. It is biologically plausible, and there's a very, very strong hint for that, and reversible, at least when we look at short-term intervention trials. And before I conclude, I just want to say this is a program of research funded by lots of different organizations we need to acknowledge. But more importantly, we acknowledge that we have worked with a variety of people across the world in trying to come to this story. I will stop here and we welcome all questions.
Thank you, Franco, for that very engaging talk. Do we have any questions from the audience? Paramjit.
Thank you very much, Franco. Really useful talk, and brings into perspective all your work and your Michelle, as well as Michelle's work to date. I just, while you were talking, you were illustrating with examples from the US and obviously the UK. But what about the Mediterranean population? Where they take naps during the day and any time of the day. As similar results are risen from there as well.
Yeah. I didn't have time to show all the things. We have done studies on napping quite extensively. Now, the story starts from the Mexico and the Mediterranean studies, where there were associations between siesta, napping, and reduced coronary heart disease. We have looked at all the Nordic European countries in modern data now, and using the EPIC Norfolk cohort study, for instance, and also in the Whitehall, when they measure napping, because they used sleep questionnaires when they asked for napping, we bumped into a very counterintuitive. So there is an increased risk of death and morbidity and mortality in people who nap. And there also is a dose-response curve. The longer the nap, the greater the risk. We looked at the total mortality, diabetes incidence, and also chronic pulmonary disease. Now, this is intriguing, but in reality, you have to think whether your napping is a voluntary nap, as in the 60s in Mexico and in the Mediterranean, and whether The napping we are measuring today, and for those who have been in the Far East, you'll be well aware of what I'm saying, is when people sleep everywhere they find the time, which is a forced nap. So that we put the hypothesis through that the napping that we see today is an expression of sleep deprivation, is an attempt to compensate for sleep deprivation. Whereas the napping of the Mediterraneans, which doesn't exist anymore in reality around the world, was a different kind. So I think the data have been confirmed by other studies, and the jury is open, but I think we need to consider the behavioral change regarding sleep. So the napping today may reflect sleep deprivation.
Dieter?
Thank you, Franco. Very nice talk. I just have a question. Are there any advantages of short sleep? I'm just thinking about you get so much more done if you sleep less. I mean, you have looked at the negative aspects.
I lost
hypertension. Pardon?
I lost you.
Okay. Thank you very much for a very nice talk, Franco. Can you hear me?
Sorry. Can you repeat the question? Yes, I lost the volume.
Yeah. I just wanted to ask, are there any advantages of having short sleep? I mean, one of the things I think about is having more time to do things during the time you're not sleeping. Have people looked also on the other side? I mean, that there are trade-offs, because everything in biology is a trade-off. There's never anything that's just good or bad.
Yeah, no, obviously there is a reason why we're cutting out sleep, and this is more in the socioeconomic domain of things. When the 24th Society has pushed us, as you know, to reduce the sleeping time, we are not idle. If we don't sleep, we do other things. Now, the trade-off has been really, I mean, there are other studies showing the trade-off has been pushed by the heavy requirements on our daily life. Just think about it, of commuting 2-3 hours every day, wasted time. And of course, you do other things. Now, we were interested in the effect on health. There are hardly any data showing that the effect on health is more if you sleep less because you do other things. The other things you do are encroaching into an activity which is not useless. But as you know, everything happens whilst you sleep, physiologically. And there is a limit beyond which I think you start damaging your health. There is a counter argument that if you go on the long end of sleep, which I haven't touched, and you go in the long sleepers, you also have an increase in mortality. This is a U-shaped curve beyond, let's say, 8, 9, 10 hours. And I think the link with causality is more difficult there, but there is one line of thinking which supports the idea that is an expression of ill health, which is not completely adjusted by the tool we have to adjust for confounders. Think about when you feel ill and you have serious illnesses at the early stage of development. One of the first things that is upset is your sleep. You tend to sleep longer. You got fatigue, exhaustion. You may just think of depression, the first thing. We always adjust for depression because otherwise you can't really interpret sleep duration, but also chronic disease, fatigue. So that is an issue which on the long side is still open, why people on long sleep have more disease and die early. And this may be a reverse causality issue still not well corrected in the epidemiology. And also there is no plausible mechanism.
Thank you, Dieter. Domenico?
Thank you very much for the very interesting lecture. I was just thinking on the clinical side, obviously, and thinking about a very specific population of people with mental illness that you were mentioning. Obviously, then there is an alternative when you intervene clinically is, do we treat the lack of sleep with medication, which in itself, they have a potential for an impact on physical health. And I wonder if you have, like, you're aware of any studies in which they explore this kind of trade-off. Do you intervene and try to help them with medication? And is the potential of medication for side effects sort of counterbalance the benefits of increasing sleep or improving sleep?
Yeah. So I think obviously our program was a public health program, so based on the establishment of sleep duration or quality as a behavioral risk factor for long-term illness. So you have to put in the context. We were not interested in, obviously we always adjusted for drug therapy and everything like that. And when we go to patient types, some of the epidemiology showed that some detrimental effects of cutting your sleeping time is usually derived by the cutting of the restorative part of your sleep. Now we go into the specific of the sleep, is the slow wave sleep, okay? The deep sleep, the one you have in the early part of the night. That's where you restore, you reset your brain. That's in normal conditions, okay? Now, for instance, for hypertension, it's been studied with polysomnography prospectively, that the sleep reduction leading to hypertension or to rising blood pressure is related mainly to the cutting of the slow wave sleep. The other parts of sleep are not related to the blood pressure, is the slow wave sleep. Now, when you use drugs, now, first of all, I think if you have a condition that upsets your sleep, my point would be you don't correct your sleep, but you correct your underlying disease. And you would expect the sleep to come over back to normal. So, but obviously, lack of sleeping conditions or mental health conditions, we're doing some studies with Latoya, I hope she's around here, where the idea is maybe sleep would precipitate relapse or other things that you may want to help. But remember, most of these drugs, I'm not an expert, will affect different phases of sleep. And they may not give you the restoration, and obviously they have additional side effects. I only have to refer to a study which I'm hooked into because I liked it. Is the Scott Weiss study on Z drugs leading to shorter life, and these are from population studies. And I think there is a message there is very clear that when we are not implying to extend sleep with sleeping pills, but it's to change behavior and creating an environment in which you can sleep the amount you need.
No, thank you. No, it's just
Okay,
that obviously when you do treat some kind of, obviously the medication that I used would have, like, I'm not only thinking about mental illness, but also to pain and stuff. The medication that at the moment we have might actually not have the full desired effect. So I guess it's still a bit of a dilemma for the clinician, like what to use.
Yes. And we've done studies with Nicole Tang on sleep and pain. And there is a clear association between sleep and pain, even when it's just, now whether you should just, you have to treat the pain rather than the sleep. Because if you then have got no pain and you get no sleep condition disorders, because obviously there is all a small margin somewhere of sleep disorders. If you don't suffer from a sleep disorder, but you are in pain, as soon as you have no pain, you sleep well.
Thank you.
Okay, thank you. We've got 4 more questions. Rahila?
Hiya, can you hear me, Franco?
Yes.
Thank you, Franco. It was really interesting talk, and I really enjoyed it after a long time speaking about this cardiovascular diseases. Franco, my question was related with the Paramjeet, what Paramjeet said about the sleep afternoon nap. I got it. What you said was really clear. I was just thinking, is there any studies, Franco, which has been conducted in the people who are working at night shift and then they complete their sleep in the daytime? Is there any differences in that sleep deprivation? Does it have the impact on their health, or it is related to any cardiovascular disease? Specifically, I'm thinking about the stroke.
Yes, no, I think very important, Rahila, very good point. We've done work on that as well, on shift work, which I didn't mention, because that's introduces another issue. It's important how much you sleep, but it's also important when you sleep. When we say we need 6 to 8 hours, which is the norm, is not what we need, but it's the norm for the current society. We're not saying that I can sleep 8 hours between midnight and 6 o'clock in the morning, or between midday and evening, there is a difference. And that's because we have a biological clock. So we have a chronotype and a biological clock that drives us the day-night cycle. And therefore, if we sleep against our biological clock, we do have consequences. Now, the shift workers are the classic example. Any shift work, independent of how you design your shift, because there are worse shifts and better shifts, the risk is between 50% higher for mortality, cardiovascular disease, cancer, breast cancer, for instance, and prostate cancer. And so working and sleeping at the wrong time of the day carries a long-term risk. If you sustain it, your exposure long time. So this is a key point. How you sort it out? Yeah, you can minimize the effects by designing rotas. And we did the only randomized clinical trials of shift work in Britain on junior doctors many years ago, showing that you can improve alertness performance and you reduce the risk of medical errors. But obviously, if you sustain in the long term, you have personal effects on chronic disease, and there is evidence about that.
Thank you, Franco.
You're welcome.
Sorry, I know Vivek is just getting second question. Just another related to the same thing about the afternoon nap. I was just, it is interesting to know, is there any studies comparing, as you said, that there's a cycle which need to be the specific time we need to sleep for this worst outcome on your health. The countries which have this culture of having an afternoon nap, does it show any positive effect on the health of the people who are having this long tradition of sleeping in the afternoon? Is there any study showing the differences between that?
Well, observational studies. Well, we know that the duration of sleep in modern society, there have been studies done with apps across the world. The reason why we sleep less is only because we go to bed later and not because we wake up early. That's interesting, first of all, and fits with the idea of the pressure of society. If you imagine you go to work, you got an entry work at 9 o'clock, you get an alarm clock, but you can go to bed 6 hours earlier or 5 hours earlier or 10 hours earlier, but you still have the alarm clock at 6 o'clock. And that is scientifically shows that is the cause of sleep deprivation, or variation in average sleep across countries. The shortest sleep duration by country, now we're going to ecological evidence, is in the Far East. There is a cluster of Japan, Korea, Singapore, Taiwan, and China. Those cluster with much less work. Now, if you go and visit those countries, is where they have the commonest pattern of daytime micro-napping. And that's why the hypothesis has been raised that the micro-napping, and therefore the relation we see between napping today and risk, is a direct relation. The more napping, the more risk, is because the napping is a forced nap due to sleep deprivation. But this obviously is hypothetical, is hypothesizing, trying to explain your observations in epidemiology.
Thank you, Franco. Thank you very much.
You're welcome.
Thank you. Deepak?
Thanks very much. Thanks, Franco, for a very insightful talk. In fact, part of my question has already been answered because I was wanting to ask you about circadian rhythm connected with sleep, but I think the chrono and the biological clock that you mentioned kind of partly answers that. What I was thinking was also the quality of sleep and things like the sleep cycle, the rapid eye movements and so on. How important are those? And also to sort of ask about, is there any data coming from wearable technologies measuring the duration and quality of sleep that might be informative?
Yeah, no, definitely there are. The question is relevant, and this is the way forward, really. most of the epidemiology we relied on, which is because we wanted prospective long-term longitudinal studies. Today, we needed to rely on studies started 10, 15, 20 years ago, where mostly was self-reported that some measured sleep quality and quantity with actigraphy. Now, obviously, polysomnography is the best way of measuring sleep, but is not has never been conducive to long-term large population studies, although more recently there are prospective studies in the US where they put lots of thousands of people on polysomnography. So we have more recent data which confirm, anyway, by and large, without refining too much, these observations. Now, in terms of the phases of sleep, some studies where polysomnography was carried out, and the study was done prospectively, showed that slow wave sleep is the critical part, which is the first part. And that's for hypertension, for instance. Now, short-term trials, now we go back to, let's say, a few days or 2 weeks of deprivation maximum, have shown that if you deprive people on glucometabolic patterns like insulin resistance and glucose tolerance, you find that if I deprive you of sleep compared to your control, or within, even in a crossover trial, I make you become glucose intolerant, insulin resistant. If I do that against your chronotype, so I make you do the same pattern, but almost reversing day and night, I double that effect, which means that the two effects are compounding. There's no reflection of the same mechanism. So you can have basically jet lag. You can sleep 6 hours in a jet lag situation, and you have still an effect. And if you sleep less during a jet lag, you have a double effect. These are reversible when you go back, but these are short term. So you can argue, how can you say that it relates to heart attacks and strokes? I can't tell you that at the moment. But the studies are accruing now polysomnography. So within the next 5 years, Biobank is one. Biobank made an error at the beginning when they did polysomnography, when they was designed, because they were all the activity people. And they made a big mistake when the 500,000 people were given actigraphy. You can imagine the amount of the investment. And they're only given to wear it during the day. And I was part of a committee sometime, because obviously Nick Wareham was interested in exercise and obesity and physical exercise. And then all this sleep story came out, and now they have a sub-study where they're given to still 50,000 people wearing actigraphy at night as well, so that they can study sleep to some extent. So just tell you how modern this new epidemiology of sleep is. So there's not much known, and all the tools are adapting now. And those the wearable devices are the one in the future. I'm having a webinar this afternoon, an international webinar, where we're talking about the importance of nocturnal blood pressure. And now there are devices that measure blood pressure and sleep at night as well, without waking you up, which is different from ambulatory blood pressure monitoring. And we hope that will open up to the importance of nocturnal blood pressure, and see whether we should treat nocturnal blood pressure, which is raised, the non-dippers, and whether that are linked to any specific sleep problems beyond the sleep apnea syndrome. So that is an evolving area of research.
Perfect. Many thanks, Frank.
Durga?
Hello, Franco. Thank you so much for the insightful talk. I was just wondering if continuity is an important factor in having the sleep. So, for example, if you have 7 or 8 hours of sleep, but it is broken down into maybe 2-3 hours of quality sleep, will that affect you?
Yes, that's what we call sleep fragmentation. Yes, it will affect you. I've focused on cardiometabolic and outcomes. Obviously, the field is much, much bigger. The effect of sleep deprivation or poor sleep quality not only affects, obviously, the long-term issues, but there are other well-known effects like tiredness, fatigue, excessive daytime sleepiness, the inability to perform, reduced reaction time, all these things. Now, if you have one, and we all have experienced that, overnight, or as you say, when you have children and you wake up several times, we have experienced what it feels like being sleep deprived. Those are temporary reversible effects. And the fragmentation does that. Now, the one aspect of continuous chronic sleep fragmentation you experience with sleep apnea syndrome. Because when you can't breathe, you stop breathing, you then snort, and you have the microarousals. The microarousals are the fact when your sleep comes to a very, very shallow level, you may not be aware of it, but your sleep is fragmented. And you can study with that. And that has terrible consequences in the long term, from fatigue, lack of concentration, and more important, sleepiness during the day. And this is the commonest cause of road traffic accidents. And the attentional failures in some professions could be damaging. And that's what we studied when we looked at the shift work in junior doctors, because you can sometimes reproduce what you're saying, the fragmentation of sleep, if you are a shift worker. And all the effects, the short-term effects, are damaging in different ways before they build up in the long term for your chronic condition. So it is an important, but there are different types of effects.
Sure. Thank you.
Thank you.
Okay. Thank you. Karthikeyan?
Thank you, Dr. Franco, for the wonderful presentation.
Thank you.
It gave a very good understanding of Bradford-Hill criteria. My question is on Bradford-Hill criteria. When we want to establish a causality, is it necessary to tick all the boxes of the criteria, or is there any minimum number of boxes that we should take?
No, of course, and first of all, this is not prescriptive. It's not a quantitative science, the Bradford-Hill. And it was a sort of a quest for causation rather than the proof for causation. In fact, unless you have a trial, even with a trial, you have to be careful. At least in epidemiology, we never use the word "I prove something" or "there is a proof." You will never see, in my papers at least, that I prove to be, I can show you something. And I think the interpretation is the issue. Now, Bradford-Hill has some key criteria, some, let's say, first rank and second rank. The second rank may or may not be available. For instance, the consistency across different places. If you don't have it because you're the first to show something, you wouldn't have consistency. Nevertheless, if the effect is strong, if the effect is, if you get the dose dependence effect, remember the time of cigarette smoking. I'll give you one little story. We now believe and we know that smoking causes lung cancer. But in all truth, by the time we reach that decision in public health and we start fighting smoking, we never had a single randomized clinical trial to show it. So Richard Dole, if you remember, did a study on doctors. It was observational. And he had to go through all the different steps. And he, for instance, demonstrated not only that smoking was associated with lung cancer, but that the more cigarettes you smoked, the more likely, the relative risk of lung cancer was getting higher and higher. So the dose response effect. He needed to get a longitudinal prospective study to show that the smoking came before the lung cancer, not after, to remove the reverse causality. So those are more stringent criteria. And there are some others. The more you have, the more you add to. And the biological plausibility, it is there. But sometimes you might bump into associations we know in the study in terms of biological plausibility will come later. And sleep is one example, because all the studies I've showed you in the small studies in volunteers came at least 5-6 years after the epidemiology of observational epidemiology showed the associations. So obviously prompted others to understand what is the mechanism whereby you become obese. And then is obviously leptin and ghrelin was easily to measure in the blood, and then all started from there.
Thank you.
Okay, thank you. And the final question from Katie.
Thank you. Thanks, Franco. It's great to see how all those different sort of pieces of evidence build up and come together. I was wondering how you see the evidence being used now for kind of intervention, or whether things are already changing in companies or countries even, do you think, and how you might track that as well to see how.
Yeah, okay. And I think that this is a layered answer. The first thing, the observational evidence, what I showed you, which we have contributed initially, but now the whole world has confirmed is a wealth of evidence. It's very easy to accrue once you have a tip, is influencing policy. We have fed into parliamentary select committees on different time, Michelle and myself, with the UK Parliament. Now, as for diet and every other things, the policy, these already would justify policy action. The problem we have, and that requires environment, other changes, so it's very complex public health measures that is not easy. The most important thing that we do not have an intervention tool. Mm-hmm. So we wanted to design a clinical trial, either as a pilot, as limited or large. The question, you need to extend sleep. You need to revert the sleep deprivation. The causes are multifaceted, societal, and we don't have a validated tool. There are several groups have done intervention trials now. There's one in Bristol is juggling with that. And you do a composite behavioral approach. And everyone is doing a different intervention. So at the moment, there isn't any standardized way of extending sleep. But it's reasonable that advices in public health that do no harm in maybe the public awareness campaign is started and trying to influence individuals to value their sleep is the first thing. Yeah. And the next step is to value society to for instance, reduce noise. Remember, noise, pollution, light pollution will make people don't sleep well. All the arguments about the runway Heathrow fits into the idea that local people sleep less. And there is evidence by epidemiology, cluster epidemiology, that people around the areas of Heathrow have on average less sleep than the others. So if you ask me how you solve that, I have no idea. Do you block flights? Do you insulate rooms? So that is something more different. So we are at the stage of increasing awareness, both amongst individuals that can try to fight the pressure and institutions that try and value sleep as a factor like healthy diet, like physical exercise. I fit sleep duration and quality into that sort of domain.
Thank you.
Franco, that was the last question for today. Can I extend on behalf of everyone present our gratitude to you for taking the time to speaking to us. Very, very interesting talk, and I'm sure not only the PGR students or the other students that are present here today have taken something away from this, but we have all taken away from this very, very interesting talk. Thank you so much for speaking to us.
Thank you for attending. This is my largest seminar attendance I've ever had, I think.
Thank you.
Bye.
Okay, thank you, Franco.
Bye-bye.